somewhere, or he took off. Last year I dedicated it to him. His name's on the window. It says Peter Carl. But, my dad's from Stuttgart. This car was built in Stuttgart. Had to have the Porsche. I used to be a Volkswagen mechanic, and this is basically a Volkswagen. It's not really your typical Porsche. So I used to work on some Porsches too. But so we'll take off the lid. So I went over some of the details last year about what it takes to do a typical conversion. It's really easy. It's not really that hard. The hardest part of electric vehicle conversion is mounting the plate and just getting yourself exactly lined. And we did have a problem with that right here. You can see that the motor is resting really pretty well touching the front axle. Or not axle, the steering column and cross gear. So you have to consider several factors, especially in a magnet motor. And I'll go over the parts in a minute. But you have to consider where you place it. On front-wheel drive, you have to consider how wide your motor is. Like in my Honda electric vehicle, it's only got about 8-inch clearance from the drive shafts. One of the drive shafts going across. So, yeah, so we keep the same transmission. Unfortunately, I blew that out a couple weeks ago. We put an 85 transmission in there, which I'm looking forward to putting out. Thing about electric motors is you got power right up front, bang. So you got to watch your transmission. We usually take the clutches out because you really don't need them, but you have to watch that you don't strip the gears. So in my Honda, I won't mention who stripped my gears the other day. So if you're like, don't accelerate hard and then...
Automatic car's okay too?
Automatic takes a little bit more work, but it can be done, it's doable. So typically you have 72 to 144 volts, an electric vehicle. You know, it really depends on the room that you have. Right here we have the front batteries. 6 batteries I can only put here. We did have a 7th on the side there, which probably I might be able to squeeze in, but actually I'm going down to 48 volts on this system. And that we have 48 volts in the back, sorry. Oop, people calling me, turn that off, sorry. So typically you have 72 to 144 volts. To get you, if you have 144 volts on a small car like this, you can probably go in the summertime about 70, 80 miles at the beginning. And then you lose battery capacity within a very short period of time. So you have to replace your batteries. You might lose half your capacity within 1 year of regular driving with conventional chargers. So with my charger, which we have here, I showed that last November. I've used that every single day, and now I'm using it in my Honda, which has the same batteries in them, except for last night we moved them over here. I've used that every day since October. That charger, which is a prototype still, we'll be selling that in the near future, but it's hard to say exactly when. But that charger has increased the capacity of my batteries about 10%. And I know exactly what's in my batteries because I go usually the same distance every day. And so typically, hello? Typically, like I said, you can go farther in the summer, 70 degrees, maybe 60 to 80 miles, depending on the condition of your batteries. And then in the wintertime, maybe I only get 30 miles. So it's not really all that practical.
Stepping on a wire.
Somebody's stepping on a wire maybe, or something. Yeah. I don't know. I'll just bear with it. Somebody maybe can call Chris, one of our guys. Can you guys call Chris out here and get him to fix this?
IT guy.
He's in there, so I can't call them. Anyway, so, you know, it's not really that practical for most people, electric vehicle, because you have this enormous cost in batteries. So $3,000 of batteries every year, every 2 years maybe, is just not worth it. You know, if you feel like maybe you want to save the earth and the environment and you're a rich man, you know, that's the typical